8.4 today. Um, so, if you haven't already realized it, chapter 8 deals with geometry. Back when geometry was studied in ancient Greece, they tried to do as much geometry as they could with something called a compass and a straight edge. So a compass, you guys have seen them, kind of looked like this. And it had like a pin on one side and then like a pencil on the other. And a compass could do two things. One, it could draw circles. So you would put the pin in the center of where you wanted the circle to be, and then you stretched the legs of the compass to be the distance that you wanted, and then you twirled the top and you could draw a circle with it. And that was really nice to be able to draw circles. Circles are pretty important in geometry, but what it also allowed you to do is duplicate distances. So they didn't really have rulers back then. I mean, I guess they did, but when they did geometry, they didn't use rulers to measure distances. They used a compass to duplicate distances. And then the other tool they had looked a lot like a ruler, but they called it a straight edge, and it didn't have marks on it. All it was there for was to draw straight lines. So if you had this length and you wanted to draw a segment that goes through that point that has the same length, then what you would have to do is set your compass up so that it matched that distance, and then you'd put the pointy end of the compass right here, and then you would put the pencil end of the compass over here, and you would draw. You didn't have to draw a whole circle, you could just draw a little bit of an arc, and then you get your straight edge, and using your straight edge you draw a segment from there to there. Yeah, that was in your last assignment. Okay. We're doing some different constructions today. So let's take a look at what you'll be doing. Okay, so this says we want to inscribe a square in the circle. Inscribe means we want to draw a square inside the circle, and not like this. When we say inscribe, we mean that the square touches the circle on all four of its vertices. Okay? So, what you need to do first is get your straight edge. Line up your straight edge in such a way that you can draw a diameter of the circle. Okay? Now, we want to build our square to look like this. All right? So we need to figure out, where should I put those two vertices? Okay? And here's how you do it. And it's hard for me to use the board to show you how the compass works. So I'm just going to draw it. You want to put the point of your compass on one side, and then you want to draw that much of a circle and that much of a circle. You can draw the whole circle if you want, but you don't need to. Okay? Then you move the compass to the other side. So you put the pin right here, and you draw part of that circle. Why would I do that? Yes, it lines up those two vertices. So now I can put my straight edge right here. And once again, I don't need the whole line, but I need to know, where does that segment intersect the circle. And now you take your straight edge and then you connect all the dots. Yeah? So it's going to make you do the whole line. So from there, your lines have to be connected. Ooh, I did a really good job. Okay. So Alex will make you do that, or it won't count. Okay. Let's look at the next one. So this says we want to inscribe an equilateral triangle in and a hexagon or a regular hexagon in a circle. So we want to build a triangle that has 3 equal sides inside that triangle. Inside that circle. How are we going to do that? Well, let's draw a diameter again. Okay. Actually, I think I can actually show you the... Let's see if I can do that. Oh, there it is. Yeah, this will work better. Okay. So, here it says put a point somewhere on the circle. And then draw a circle that uses the center as your pencil and that point and the point B as your pin. Okay, and then you can keep doing that all the way around. So what it's saying is, go away. So we put our pin here and we put our pencil here, and we can draw a little bit of a circle, and actually you could do it the other way around too. And then you move your pin to here and you use the same distance, and if you do that all the way around, you end up with 6 equal distances. And then you can either draw... Does it want you to do both, or do you remember, Kaysen, you did this, right? Oh, okay. So there's your triangle, and then your hexagon would look like this. Okay? Okay. So for this one, we have a parallelogram with those vertices. So I'm going to graph it 1, 4, -6, 4, -5, or sorry, 5, -5, and -2, -5. Okay. How do we find the perimeter? Remind me again what perimeter is. All the sides added up. So do I know any of these sides pretty easily? Well, the top and the bottom can be counted. So there's both 7. How do we find the length of a slanted line segment in the coordinate plane? So we need to turn them into a right triangle. So you count the y distance. So the y distance is 1, 2, 3, 5, 6, 7, 8, 9. And the x distance is 1, 2, 3, 4. What do I do with those? Well, we have a right triangle, 9, 4. Would this be A, B, or C in Pythagorean theorem? C. So 4 squared plus 9 squared equals C squared. That's 25 plus 81, which is 106. Okay, take the square root, and I get C is the square root of 106. Okay, so if this is the square root of 106, and this is the square root of 106, then my perimeter is 7 plus root 106 plus root 106, which is 14 plus 2 copies of root 106. And it says it does not want the decimal answer. Yeah. Oh my goodness. God, one of you is paying attention. How about 16 plus 81? So that is 97. So it's 14 plus 2 copies of the square root of 97. Thank you, Casey. 4 squared is 16, not 25. But do you guys understand that? Okay. Okay. What is the area of this triangle? Does anybody remember the area formula for a triangle? Close. Area equals 1/2 base times height. Okay. And what do we mean when we say base times height? Well, this will be the base. And what's the height? Would it be the left side or the right side? Nope. It's actually neither. So the area is half of the base times how tall it is. And there's a really easy way to remember this formula. So everybody pay attention to this. If I built a rectangle around this, then the area of that rectangle is base times height, right? But this triangle here is the same size as this triangle here. And this triangle here is the same size as this triangle here. So a triangle is always half as big as the rectangle that you can draw around it. So the formula is really easy. It says, find the area of the rectangle and then just cut it in half. So we can figure out this distance really easily. We go from -6 to 3, which is 9. And then how tall is this triangle? Well, it goes from -6 up to, look at the y values. We go from -6 to 2, so it's 8. The rectangle has an area of 72 square units. So the triangle must be 36 square units because it's half as big as the rectangle that you can draw around it. Okay. So here we have a rectangle. And we'll graph it at -3, 7, -3, 2, no, -3, -2. And then at 1, -2, and 1, 7. So this distance is 1, 2, 3, 4. And this distance is going to be 9. So the area will be 4 times 9, which is 36, The perimeter will be 4 plus 4 plus 9 plus 9, which is 8 plus 18, which is 26. That one's easy. Okay. What do we call a four-sided figure? If a polygon has four sides, what's it called? Quadrilateral. 5 sides? Pentagon 6. Hexagon 7. It's heptagon 8. Octagon, what about 9? So think of our months. September, which our calendar's off because they added a couple months in there, but September was supposed to be the 7th month. October was supposed to be the 8th month. November was supposed to be 9, and then December was supposed to be 10. And the calendar had 10 months. But there were 2 Roman Caesars who decided they wanted their own months. Their name was Julius Caesar and Augustus Caesar, which is where we got the months July and August. And of course they put their months in the summer when it was nice and warm. Messed up our whole calendar. So a 9-sided polygon is called a nonagon. Lines up with November. And 10-sided? Nope, that's 8. Decagon. Yep, decagon. And then once we get bigger than 10, we just say an 11gon or a 12gon or a 45gon or a gigantagon or something like that. Okay. So, how do we draw a circle with the diameter of 2 units? So, we want to draw this circle, and I want that length to be 2. So, I use my compass, and I set the width of the compass. I put the pin here. How wide do I need the width if I want the diameter to be 2? Well, a compass deals with a radius, so I need to set my radius at 1, put the pin here, and then draw that circle. Oh, that's it. Okay, get to work.